Hello there. In this problem, we're going to be using superposition to find VO across this resistor. To use superposition, we must have linear circuits. And in this case, we do have a linear circuit, so we can apply the concept of superposition. The whole idea behind superposition is that the total response is the sum of the individual responses. In this case, VO is our total response. The individual response is the voltage across this 20 kilo ohm resistor due to this 5 milliamp current source plus the response to this 25 volt voltage source. And we add those up, and that would be our total response, VO. Now, to use superposition, we zero out one source at a time and find its response. We zero out voltage sources by shorting. We zero out current sources by opening. Then we have our system of equations, and we solve and we add the individual responses together to find our total response. Now, a word of caution is that we do not zero out dependent sources when using superposition. So do not zero out or deactivate dependent sources. Okay? Okay. Now, let's start by deactivating or zero outing this voltage source, 25 volt voltage source, by shorting it. So we replace this voltage source by a wire shorting this side. So down here, I have shorted this 25 volt voltage source. Now what we're doing is finding the response due to this source, this 5 milliamp current source. So we have to find VO due to this source. So let's use, well, I like to use node voltage analysis, and we'll just do that right here to clear our nodes. Node A, node B. Okay. Now let's find the currents going in to node B and the currents going out node B. Okay. We have 22.2 I sigma going in to node B, right? So the currents going, using Kirchhoff's current law, the currents going in is equal to the currents going out. So we have one current going out, one current going out, and no current going out because this is an open circuit. So we have one current. So what's this current? Well, let's call this I1 for now. You'll see later because I1 is equal to these currents going out of node A. So we have I1 plus this current through this 20 kilo ohm resistor. So VB over 20 kilo ohms would give you the current. Using Ohm's law, V equals IR, but V over R is equal to the current. But you can see that VB, this voltage here, is the same voltage as VO, even with respect to ground. So we can replace VB by VO. So VO is equal to VB. So we have VO, this current going down, is VO over 20 kiloohms. Okay? Okay, now that was node B. Now let's do node A. So what are the currents going into node A and what are the currents going out? Now the currents going in is I1. I1 is equal to, we have a current going out here, I sigma. What is I sigma? It's VA over 4 kiloohms. See, okay, using Ohm's law, V equals IR, right? To find the current, we divide both sides by R, and we have voltage over the resistance is equal to the current. Okay, now this voltage is VA, which is the same voltage as VB. So, and VB is equal to VO. So we can say that VA is equal to, excuse me, VA is equal to VO. Okay? So this current on out is VO over 4 kiloohms plus this current, which is 5 milliamps. Makes it a lot simpler because it's a current source. 5 milliamps. Okay. Now, you need to remember that when you're doing circuit analysis, whenever you have a dependent source, you have to write a constraint equation. That's another equation you have to write. So whenever you have a dependent source, you have to write another equation. Okay. Um, what is so we have to so because this is dependent, I sigma is dependent on this current going through this 4 kiloohm resistor. We have to find what I sigma is. I sigma is found is this current, which is the same current as this. So it's VO over 4 kiloohms. Okay? Now we can substitute. Now my substitute I sigma into there and I1 into here. And we'll have an equation. We'll have that 22 I sigma in V times VO over 4 kiloohms is equal to I1 to substitute, so VO over 4 kiloohms plus 5 milliamps plus VO over 20 kiloohms. See, now we have one equation and one unknown. Our one unknown is VO. It's just VO due to this 5 milliamp current source. And when we use our handy-dandy calculator, we can solve this, and we'll find that VO is equal to 20 volts. 20 volts. But remember that we're doing superposition, so we only found the response due to one source, which is 5 milliamp current source. So essentially, VO is actually VO1. So 20 volts, and we'll have to add 20 volts to the response due to the current source open to the zeroing out current source. Okay, which we'll do next. Okay, we are zeroing out the 5 milliamp current source by opening that part. So that part of the circuit right here will be open, and we'll find the response VO due to this voltage source. Now to find the response due to this voltage source, we can do node voltage analysis again. We'll declare this as node A, declare this as node B, and declare this node as node C. Okay. And right away, like our previous part, we can see that VB is equal to VO, which is the same voltage as VA. This can be seen in this problem, where VO is the same voltage as VC, which is the same voltage as VB. Okay. Okay, so we say that VO is equal to VB is equal to VC. Okay. And we can see that VA is a 25 volt rise with respect to ground. So VA is equal to 25 volts. So that means we only need to use node voltage analysis at node C. Because we already found what VA is, we know what VB is VO, which is the same as VC. So at node C, what are the currents going in and what are the currents going out? Node C, we have 2.2 I sigma, which is this current going into node C. is equal to the current going out there, the current going out there. Well, what's the current going out here? That's I sigma. I sigma is the current going here, so we must find the voltage here. Let's find the voltage here. So I sigma, I'll just write this down here. I sigma is equal to VC, which is VO, minus VA, what is VA? 25 volts. 25 over this resistance, 4 kiloohms. And how do we know that? Well, using Ohm's law, we rearrange Ohm's law. Say that V, the voltage over the resistance, is equal to your current. Okay? Okay, now we found what I sigma is. So that's that current. So this is I sigma, right? Okay, we have this current going in, this current going out, this current going out. With this current going out, plus VO over 20 kiloohms. Okay, now we can substitute this into here, and we'll solve where VO is. Okay, so we find that VO would be equal to 30 volts. Okay, 30 volts, but this is a response due to this 25 voltage source. Okay, so it's essentially VO2 is equal to 30 volts. Now we must find the total response. To find the total response, we add VO1, 20 volts, plus VO2, 30 volts. And we'll get the total response. So VO is equal to VO1 plus VO2, which is 20 volts plus 30 volts is equal to 50 volts. That's VO. That is our total response right here. So, to summarize, when using superposition, you want to find your total response due to the individual responses. You zero out one source at a time. To zero out voltage source, you short the voltage source by replacing it by a wire. To zero out current sources, you open the current sources by replacing it by an open circuit for that part. And then you write your equation, you solve for your response due to each source. And do not zero out dependent sources. Do not zero out dependent sources. So thank you for watching and good luck.